Okay, in this video I'm going to take a look at the torque limiter. That's the map here. Winols often finds this, so it's not that difficult to find, and the shape is fairly characteristic. This one has got 4 little bumps. Sometimes there are 3 little bumps, sometimes only 1, and occasionally 2. Each little bump is usually an air pressure, so in other words these might be 700 millibars, 800 millibars, 900 millibars, 1000 millibars, something like that. So they're usually 1 bump per air pressure, and the values within that bump are the values that we're interested in. And so if the manufacturers decided that air pressure wasn't that important, then they would decide that they could have less of these little bumps. And if we look at that in more detail, we can see what we've got here is not quite the values I said, but we've got 700 millibars, 800 millibars, 850 millibars and 900 millibars. So that's the air pressure, and we've been given different air pressures because it's to allow for the fact that if the car stops driving at what would be sea level, somewhere around about 900, and starts driving up a mountain to about 700, the available torque would change slightly, not a huge amount, but it would change slightly because the turbocharger would find it harder to compress the air because the air was thinner. So that's why this is different, but in fact the difference is not very great on here. But VW have been nice enough to put those possible changes in for us. Now on this axis we've got engine speed running up to 5,500 revs, but you can see that by 5,200 revs the torque is pretty much down to 0. In other words, it's getting very low. By the time we get to 5,400 you can see how low it's got, and by the time we get to 5,500 the actual torque has been limited to 0. All of this is designed to protect the engine. So the torque, which is this value on the output of the map, has been given a maximum value of 377 newton meters. That's somewhere in the region of 2 to 2,500 revs per minute, and after that it starts to go down. So it's just to protect the engine. As the engine revs rise, it puts less strain on the engine. So in other words, there is no point in this engine revving because you won't actually get much more out of it. You might get some more power along here because torque and power are not the same thing, so you might get a little bit more power as the revs rise, but the amount of torque that you're developing is not going to change. If anything, it's going to go down in order to protect the engine. And as before with these things, the value that we're using here is 0.1 for torque, so we're using a factor of 0.1. So we've got torque map, torque in newton meters, 0.1. We've got air pressure, no factor, so it's still 1. It's atmospheric pressure or air pressure, it's HPA or millibars, which is the same thing. And if we look at the other axis, we've got engine speed, revs per minute, and we're using 0.5 as before. So it's pretty much what you would see if you were looking at an EDC16 file, so no great change. Works just the same way pretty much. So in other words, what we've got is just a method of making sure that the driver's wish is not requesting a value that is just going to break the engine. So in other words, this is sort of like stepping in after the driver's wish and saying, no, we don't want those figures, because if we use those figures the clutch is going to rip, the gearbox is going to break. In other words, something is going to give, it's not going to be okay. So that's what this map is doing really. Okay, I'll stop at that point.